So this is another very interesting problem, and it comes from an integration bee from University of California, Berkeley. It looks very complicated, but it's not. It's quite easy. So it's the integral of x times the square root of x to the power log x times within the square root sign cube root of x to the power log squared x. Within that cube root sign, we have the fourth root of x to the power log cube x. Within that fourth root sign, we have the fifth root of x to the power log the power 4x, and so on and so on. So the way we could try to solve this equation is as follows. So first, we would have to let u be equal to log x, so that du dx is 1 over x, and e to the power u is the same as x. And therefore, eu du is equal to dx. And then if we look at the limits here, when x is equal to 0, log of 0 tends to negative infinity, and when x is 2, log 2 is equals to u. Therefore, our integral in terms of x now becomes integral from negative infinity to log 2 of e to the power u in place of x, square root sign e to the power u in place of x, and log x is therefore u and cube root e to the power u in place of x, in place of log squared x we have u squared, and so on. So we can now rewrite that considering square root sign as the power half. So we have eu times u is equals to the power u is u squared, and then the square root sign it's therefore times a half, so we have u squared over 2, and then inside the cube root sign we have u times u cubed as the power, so we get times u squared as the power. Now we have u cubed, and then this cube root times square root, so it's the power third times half, so we get the power 1 over 6. And then inside the fourth root sign we have the u to the power 3 times u, we get u to the power 4, and then we have obviously the cube fourth root, which is 1 over 4 times 1 over 3 times 1 over 2, that is to the power 1 over 24. So it's u to the power 4 over 24. And for the fifth root sign, we have u to the power 4 times u, which is u to the power 5, and then we have a fifth times a quarter times a third times a half. All that gives us 120, and therefore we have u to the power 5 over 120, and in place of dx we have obviously eu du. And so we can simplify that further by collecting like terms. So we get e to the power 2u, we brought this u and multiply to this e to the power u, and so u squared e to the power u squared over 2, e to the power u cubed over 6, the power u to the power 4 over 24. And if these spaces are the same, we can use the properties of indices where we just add the powers. So e to the power 2u remains that way, and then e to the power u squared over 2 plus u to the power 3 over 6 plus u to the power 4 over 24, and so on. Now, as you can see, 2 is the same as 2 factorials, 6 is the same as 3 factorials, 24 is the same as 4 factorials, 120 is the same as 5 factorial. So we can express now the entire expression as e to the power u times e to the power summation of from k is equals to 0 to infinity of u to the power k over k factorial. We've included this e in the denominator because we've decided to add another e to the power 1 in the numerator to make this summation complete from k is equals to 0, so that we have e to the power 1. And so the equation now, with that summation, we can pull 1 over e out, but also looking at this e to the power summation of u to the power k over k factorial from k is equals to 0 to infinity is the same as e to the power u. So we do have our equation becoming 1 over e times the integral of from negative infinity to log 2 of e to the power u times e to the power u. Now, this is a straightforward integral, but just to make it obvious, we can say let y is equals to e to the power u, so that dy is the same as eu du, and therefore 1 over y dy is equals to the same as du. And then when we plug in the limits, negative infinity, e to the power negative infinity, 0 tends to y tends to 0, log 2, e to the power log 2 is the same as the value 2. And so now the integral becomes 1 over e times integral of 0 to 2 of y times e to the power y times 1 over y dy. These y's cancel, and so we're left with just a simple integral of e to the power y from 0 to 2 times 1 over e, and that becomes 1 over e times, because the integral of ey is the same as ey, that is plugged in there. So the answer is 1 over e times e squared minus 1, e to the power 0 is 1, and so the final answer is e minus 1 over e, and that is our final answer. So before we end, a quick reminder for those of us who have not subscribed, please subscribe to our channel. It helps, gives us that extra profile and visibility.